Okay, welcome back. So I mentioned in the last video, if you guys are watching it, nobody's watching my videos, honestly, in this class. I'm a little disappointed, but maybe these series ones will get you. I mentioned that I didn't really understand Taylor series. I mean, that's not true. It's understanding is like this fluid concept. And so the reason I said that is because when I first learned these things, I thought, oh my God, I have to take all these derivatives. But the point is to avoid taking these derivatives if I can. So let's take a few just to sort of get a feel for it. Okay, so some Taylor series without taking derivatives. Okay, so here's one of the power is that if you have a power series representation for a function, it is the Taylor series. Okay, I mean at a certain point. Okay, so e to the x is 1 plus x squared. Oh, sorry, plus 1 over 2 factorial x squared plus 1 over 3 factorial x cubed. The sum n goes from 0 to infinity. 1 over x factorial x to the n. This is about x equals 0. Okay, so let's take a look at, let's say, we already kind of did one similar. Let's say e to the 2x. Okay, e to the 2x is going to be, n goes from 0 to infinity, 1 over n factorial. We're just going to write 2x instead of x. Okay, that's simple as pie, right? Easy peasy lemon squeezy, as they now say. Okay, all right, let's do cosine of x. Cosine of x, we know, is the sum. N goes from 0 to infinity, negative 1 to the n, over 2n factorial. X to the 2n. Okay, so let's take a look at x times cosine of x. Well, we can just multiply this thing by x. So n goes from 0 to infinity, negative 1 to the n, 2n, I should have written 2n there in parentheses, 2n factorial, x to the 2n plus 1. Okay, just like that. No problem. Okay, let's do another one. Let's find the Taylor series for f of x equals sine of x about a equals pi over 2. Now again, I could do this using the derivatives. I could take the nth derivative of sine of x at pi over 2, but that's gotta be a pain. Instead, what I'm gonna do is I'm gonna say, okay, you know what? I'm going to write this as, let me just, let me imagine I'm doing this. This is going to be the sine. F of x is the sum. N goes from 0 to infinity. Not doing it yet. I'm just doing it sort of in my head or abstractly. The nth derivative at pi over 2 over n factorial x minus pi over 2 to the n. Okay, but let's do a change of variables. Instead of x minus pi over 2, let's call u x minus pi over 2. Okay, so we're now going to do find the Taylor series of actually x plus pi over 2. Okay, watch what I mean here. Oh, let me check that out. I should have written it a little clearer for myself. So we're going to find the Taylor series of sine of, yes, what we want is we want x minus pi over 2 to be u. Okay, so we're going to do sine of u. Okay. Uh, Let me come back to this one. I'm going to keep what I did before, but I'm going to come back to me. So pause the video.